the class now. Am I audible? Am I audible now? Wait, I will check. Now am I audible? Yeah. Shall we start the class now? So first, good evening everyone, good evening. In our previous classes, we discussed the creation of battery model by using Simscape battery. This is very important because it helps us to understand how real life battery models work in electric vehicles and other applications as well. In previous classes, we were taught by creating the basic building blocks of our battery module and then move on to cell creation and parallel assembly. Once we have these components already, we will use some special tool that is called build battery. And this build battery to put them together and create our battery model. It's like creating a digital version of our battery model that we can use for the various simulations and experiments. So today we are going to talk about build a simple model of battery pack. So in previous classes we discussed battery module and today we are going to talk about battery pack. To design this battery pack in Simscape or a Simulink software, we will start by creating the individual battery cells and then group them into the parallel assembly, which are further organized into the models, and finally we assemble these models to create a complete battery pack for various applications. So this is our complete process. In previous classes, we covered this battery model and today we are going to create a battery pack for various applications by using Simscape Matlab software. If you really like this session, hit the like button now. So before we enter into the complete process, first we already know what is cell, a parallel assembly, model assembly. Do you have any idea what is cell, parallel assembly, model? Give your answer in the comment box. What is cell, what is parallel assembly, what is model? So these are all the things we discussed earlier. What is cell, parallel assembly, and then module? Now module assembly. At last we have a battery pack. Leave your answer in the comment box. Okay, I will tell you. So first, cell in the sense, this is like a single battery. It is the smallest part that we can store our energy. So just like the battery in your TV remote. Next one is a parallel assembly. Yeah, of course. Pretty, yes, cell is a single battery. Next one is parallel assembly. What is a parallel assembly? Imagine you want to make your battery more powerful. So at the time you can take the several cells and connect them side by side like stacking bricks. So this group of number of connected cells, this group of cells connected together, that is called parallel assembly. It's like using the multiple batteries in parallel to increase the overall capacity. Now module. So now this module is a group of these parallel assemblies. It's like a big box filled with these group of cells. Next one, module assembly. To assemble means to put something together. In this case, module assembly is the process of arranging these group of cells in a certain order to make a larger unit. Yeah, very good, Habi. Very good. So at last we have a pack. So what is a pack? It is a final product. It is a complete battery system that we are going to use in devices, vehicles like that. So it's made up of modules, and which modules are made up of parallel assemblies and which are made up of cells. So it's like a building battery. So now we are going to create first cell object and parallel assembly object and module assembly pack. So difference between the battery module and battery pack. So this is the main difference between the building a simple model of a battery pack and the battery module in the Matlab and Simscape to view the scope of the simulation. So this battery pack, it's look like a battery pack in the sense it looks at the entire battery system with multiple models, while the battery module focuses on the behavior of single model within the pack. So this is the difference between the battery pack and battery module. So the choice between them depends on our simulation goals and the level of detail required for our analysis. So this is the main difference between the battery module and battery pack. So battery pack in a sense is like an entire battery system with multiple models, while the battery module focuses on the behavior of single model within that pack. That is the difference. So today we are going to design this battery pack, and for that here we are taking pouch cell. So in first class we saw the cylindrical structure and prismatic and pouch. So these are all the common structures available in battery, and today we are going to take the pouch cell. So for creating that pouch cell battery pack, so first we need to create the cell object and parallel assembly object and create the module object and create the module assemble object and create the pack object. Next we are going to visualize the battery pack, how it's look like. So by using this visual code, we are see the blueprint of the battery pack. Next one, check the model resolution. At last, we are creating this block as a library in our current folder. So let's open the Matlab software here. This is our Matlab home page. Here you can see this is our command window. This is our Matlab editor page. So in this editor page, I have already put all the code to explain this page for you. Here I took this example from the MathWorks website. Here I am using Matlab version 2022B version. So first we need to open the toolbox for creating this battery pack. So for that, click on this and evaluate into the command section window. So wait. I will change the font size. I will increase the font size. Now it's okay. So first, think of import. So it's like opening a toolbox when you import something in Matlab that we are getting ready to use some set of tools or functions. So this is what that import simscape.battery.builder. So this part specifies the location or a folder where Matlab should look for those tools or functions. So it's like telling the Matlab where to find the right toolbox in our simulation. Yeah, 2023A version will be suitable for this projects and this simulation. So here this store, it means you want to import everything inside that toolbox. You are bringing in all the tools and not just one specific tool. So this is like opening a toolbox, that is called simscape.battery.builder. So next we are going to create our cell object for the pouch geometry. So this is our code. Evaluate in a section window. Here you can see this is our pouch geometry. That pouch geometry, we will enable the some features. So first, begin with the cell object. Here we are using a pouch geometry. This pouch geometry, we will enabling the height and radius of the pouch geometry. First, this is pouch geometry is a blueprint or a design template for creating our specific shape of a battery like a pouch. So what is the height here? So this height, this part, how the tall battery is, it's said to be the 0.1 meters, which is like a 10 centimeter. And length, what is our length? So the length will be 0.3 meter. This part tells how long the battery cell is. It's said to be 0.3 meters, which is like a 30 meters. Here you can see another one important method. So this algorithm and this code only for internship user. So this tab location, here you can see this tab location, this part describes where the electrical connections called tabs are located on the cell. So they are positioned, that is opposed to each other, meaning they are on opposite sides of the cell. So that's why this code described. So next one, in simple terms, this line of code is like giving instruction to make a battery that looks like a pouch structure. It specifies the battery's height, battery's length, and now the electrical connections are arranged. This is what this tab location. So next we are going to create battery cell geometry equal to pouch geometry. So evaluate selection in the command window. So this code helps to describe the shape of the battery cell that look like a pouch structure. You can use it to specify how tall and long the cell and that battery is, height and length. So then where the electrical connections points or tab locations also we enable. So this objects like a blueprint for the physical characteristics of the battery cell. So next we are going to create battery cell. So geometry equal to pouch geometry, in the sense inside this we are providing some specific instructions for how to build this battery cell. So geometry, in the sense it's like specifying the design and shape of the cell. Next, pouch geometry is the name of the design or blueprint we have defined earlier. So we are saying use this design called pouch geometry to build this battery cell or a battery pack. So that's why we are mentioning into the Matlab. So simple terms we can say this code tells Matlab create a battery cell and use this design called pouch geometry to shape it. It's like giving a builder plan, a detailed plan to construct something according to our specification. So that's we are going to give into the Matlab command window. So next we are going to create parallel assembly object here. So in this parallel assembly object, we are run this code here. So first we need to create our parallel assembly. So we are telling the Matlab to make a group of battery cells that are connected in a parallel manner. So that means like putting several batteries side by side. So next, cell equal to battery cell. So cell in this inside this parallel assembly, cell equal to battery cell. So inside this group, we are specifying what type of battery cell we have to use. In this case, we are using the battery cell that we created earlier, which represents a single battery cell. So next line, the number of parallel cells will be 3. So we are also saying that we want 3 of these battery cells side by side in this group, all connected in a parallel manner. So after running this code, we have created a battery parallel assembly with the 3 batteries with 3 battery cells, like having a 3 batteries together arranged side by side and connected in a parallel. So this group can now be used as a part of a larger battery system. Next, we are going to create a module object. So this module object, so what is a module object? This battery module comprises the multiple parallel assemblies that are connected in a series format. So for that, I will run this code. Here you can see. So first, we are creating our battery module. That means we are creating our battery module. That means we are telling the Matlab to make a battery model which is like a larger unit. That unit made up of a smaller groups of battery cells working together. So that is called battery module. Next one, parallel assembly equal to parallel assembly. So inside this model, inside this battery module, we are specifying the type. We are specifying the type of a parallel assembly to use. In this case, battery parallel assembly we created earlier, which contains the 3 battery cells connected in the parallels that we are going to inside this model. So next one, number of series assembly is 11. So here you can see number of series assembly as 11. So we are instructing the Matlab to use 11 of these parallel assemblies, the ones with the 3 cells each. So we are instructing to the Matlab to use 11 of these parallel assembly and connect them in a series form. It's like stacking 11 of these groups on top of each other. So at last I will show you the battery pack. At the time I will explain. So next we are giving the space here. So interparallel assembly gap. Interparallel assembly gap. So we are also defining a small gap of 0.005 meters. That means 5 millimeters between each of these parallel assembly. So this parallel assembly, this space separates the groups within that module. So within that module, we have to create a some space. That space will be 0.005 meters. Okay. So next we are creating. So this results that we have created our battery module with the 11 groups of 3 battery cells each in a series. So with a small gap between them. So this model can be used as a building block for our larger battery pack systems. So that's why we are giving this much information to our model. So the session will start at 6 to 7 p.m. daily. So next, we are create a model assembly object. So that is the next step. We are creating model assembly object. So for that, so what is model assembly? We know. So it comprises the multiple battery models that connected in a series or parallel manner. Now I want to run this code. Evaluate instruction window. Okay. So what is that? Here what will happen? So here this battery, module assembly. So this is our code. This battery module assembly model. So we are creating the battery modules which are like a big boxes that used to store some things. So here these are rep mat. So that means that we are making a 2 identical boxes. That means 2 identical battery modules using a design a battery model that we have prepared earlier. So think of these two boxes as a two large one empty suitcase. So each suitcase represents a battery model. They exactly like the same inside. So just like when you have identical empty suitcase. So we are going to create this model assembly. So inside this model assembly, we are creating some gap. So we are specifying there should be a gap of about 0.1 meters, that approximately the width of shoe between these two big suitcases. So this big suitcases, in the sense, that is a battery model. So next, this code create a battery model assembly. That means by putting two battery models next to each other with a small gap between them. So that is why we are giving this information to this Matlab command window. It's like arranging two battery models side by side with a small gap between them. So next, Anand Srikar, I will clear your doubt at last. So first we will finish this one. So next we are going to create pack object. So at last we have to create our battery pack. Okay. So before this, I want to tell you something. So join our internship today. So in this internship, with fantastic benefits, including 30 days of live sessions, 90 days of access to records, and 10 plus BMS source code. So these are all the source code, and some algorithms also will be there, active cell balancing and simulation files, lot of simulations files that we are going to create, and 30 days, 30 downloadable presentation, and also you have a 6 mentor mastermind sessions and internship confirmation letter and internship certification. So it's all in a one package. So use this opportunity, join our internship program today, just 999 with the coupon code of BMS MC1. So by using this coupon code, the fees will be 999. So it's an affordable way to access your valuable knowledge and mentorship and hands-on experience like that. So don't miss this opportunity to kickstart your career in an electric vehicle and BMS field. So during this internship, you will get a work on a variety of exciting projects. So this includes a task like creating the basic battery model simulation and designing models that considers the temperature effects and becoming an expertise in estimating the state of charge and state of health, building the battery packs with advanced features, and by using the Coulomb counting and Kalman filter. So these are all the methods, the advanced methods to calculate the state of charge and state of health in a battery, and also generating code for a BMS and designing a 1 RC2 RZ equivalent circuit for a lithium battery, and also we have a closed loop testing for BMS using a Matlab. So these hands-on experience and real-time experience will equip with your valuable skills in the electric vehicle and BMS field. So register now. Join our internship today with the discounted fees 999 by using this coupon code BMS MC1. Join today. So don't miss this opportunity. So let's back to our Matlab window. So this is our battery model assembly. So next we are going to create our pack object. So now we are going to create a battery pack here. So for that, so once you have all the foundational elements to create our battery pack, that comprises the multiple module assemblies that contain in a series or a parallel manner. So here we are going to create our battery pack object here. So for that we need to run this code, evaluate in the comment section window. So first, this is a battery pack. Inside this pack, this one is a module assembly. Inside this pack, we have created a module assembly equal to rep. So mat battery module assembly. So we are creating a battery pack here, right? We are creating battery pack here, which is like a collection of multiple battery module assemblies. Remember, so module assembly in the sense there are a big, already we created a big battery module assembly with a small gap between them. So next, that means, so this rep mat battery module assembly 1,5. So this means, here you can see 1,5. So this means we are making a 5 identical battery module assembly using the same arrangement which we created later. So here now just we are using 5 identical battery module assembly using the same arrangement we created earlier. So that's why we are specifying here, right? So next, intermodule assembly. So intermodule assembly in the sense we are specifying there should be a gap of between that battery modules is 0.01 meter. So which is roughly the thickness of one coin. So between these 5 sets of battery modules, we have created some gap between them. So that is called this intermodule assembly gap, 0.01 meter. So in simple terms, we created this battery pack by arranging the 5 sets of battery modules side by side with a small gap between each set. So that is what here we are giving this information to this Matlab command window. So next we are going to visualize the battery pack. So for that, visualize the battery pack, we are going to display our battery pack num models. Now we are going to run this model. So when you run this code, it will be 10. So the result will be 10. So this 10, it specifies it represents the count of a Simscape battery that used in our battery pack simulations. So here 10 battery pack simulations we used. So basically, this line of code, it will showing that there are 10 simulation models or components within our battery pack. So these models are used to simulate how the battery pack works under different conditions and helping you understand its behavior in various situations like that. So that's why here we are putting this command here. So next we are going to enable this function here. So to visualize the battery pack, we are going to enable the battery chart. So that means chart. So enable this function to the command window. And here we are creating a sum battery chart. So by using some settings and information. So for what is the purpose of chart? So here you can see this is our battery pack. So finally we created this one. So we are enabling this battery chart. We are enabling this battery chart here by using some settings. So this is that code. So battery pack chart equal to battery chart. This means parent is a UI figure. So this means this chart will be displayed within some user face figure, which is like a window where you can see something. So that is why it's specified. Next one is a battery equal to battery pack. So this indicates you want this chart to represent your battery packs, that what you have created. So that's we are see by using this battery chart. Next one is a simulation strategy visible on. So during this simulation, our battery model look like. So that's why we are here enable this in the on mode. So now we are see this is our battery pack. So here this is our battery chart. We make some special chart to show our battery pack. So this battery chart, so we created 1 to 5, so it's total 10. So with a small gap in between them. So this is what we are giving that function, that information to the Matlab. So finally we created. So Gopal Chandra Sagar, this is a pouch shaped battery pack. I said example of battery model as a suitcase. So it's a pouch shaped one. So next we are going to save this function in our current folder as a pack library name. So this build battery functions. So you can see this is our build battery. We are enabling this one. So I need to change this one because I have already created. Evaluate in comment section window. So now you can see your current folder. So in this current folder you have a pack library too. So I will show you after that will complete. So double click on this. Here you can see this is our pack2 library SLX format. If you really like this session, give the thumbs up in comment box. This is our overall battery models what we created. Wait. This is our parallel assembly. And this is our, you can see. This is our battery pack and model assembly. So click on this. Here you can see. There are 5 battery model. So with some gap between them. Thank you all. Thank you for your reply. So inside this we have all the battery model. And this is our battery pack object. So successfully we created that one. If you really want this code, join our internship today with a discounted fees at 999. So use this coupon code is BMS MC1. If you want PPT and code, thank you all. Thank you for your active response. Do you have any other queries? Do you have any other queries? Do you have any other queries about cell, object and pouch geometry like that? So enable this pouch geometry. You can see how it's look like. Wait. I will share this PPT and code. So register today join our internship program. I will wait. I will show you the pouch geometry. Copy this code, evaluation in comment section window. So this is our pouch geometry. Inside this battery pack, we have this type of battery structure inside this battery pack. So this one for a lithium ion shukla, this one for a lithium ion cell. So here we specified one thing. So that is a tab location. Where is that? Wait. So here the tab location is opposed. That means this is our tab location. Here you can see. This is our tab location. So opposite side we have this model. So join today with discounted fees at 999. If you want this code, if you want this PPT and algorithm and simulation file and this library file, if you want, really join our internship today. So this tab location, yeah, of course, only for internship students. So here we specify the tab location in opposite side. This tab location, it enables the electrical connection points, that is called a tab. So that are located on the each side of the battery. Each side, that means opposite side of the cell. So the length should be what? The length should be 0.1 meter. So that is the length, and it specify the height should be 0.1 and length should be 0.3. So 0 to 0.3 is the length and 0.1 is the height. So this is our pouch shaped battery pack. So finally we created this as a battery pack. So we have a 5 battery module assembly inside this pack. So we specify here. So we specify here. What is that? 1 to 5. We have a battery model assembly. This is our model assembly. And inside this, we have a small space. So that is a 0.001. 0.01. Here you can see. So let's summarize the session now. Do you have any doubts or queries? Mention in the comment box. I will answer. Otherwise, we will summarize the session now. So in previous classes, we cover how to design battery model. So that only one model we created. Now we have created a battery pack. Inside this battery pack, we have a 10 battery models. Do you have any other queries? let's summarize the session. The entire process from the first line of the code to the end. So if you really want this PPT and want this code, join internship today with the 999. So just a discounted fees 999 by using this coupon code BMS MC1. Okay. So first we are defining our battery components here. So first we are defining our battery components. We begin by defining the fundamental components of our battery system such as a cell, parallel assembly, module assembly, pack. So next we are configuring the battery geometry. What is a battery geometry? So here we take a pouch structure. So that's why we specify that structure name pouch geometry, and in that pouch geometry so we add the physical characteristics of the battery cell. What is that? Size, height, length and tab locations like that. So next we are creating the batteries. So with this geometry information we have created the individual battery cells, setting properties like mass, capacity, energy like that. So next one, multiple battery cells that are grouped into the parallel assembly, where you can decide how they are electrically connected and specify the number of assemblies like that. Next, building the battery models. So this battery models comprising the number of parallel assemblies are created by specifying the number of parallel assemblies to connect and gap between them. So next, constructing our model assembly and then assembling the battery pack. So the final battery pack is assembled by arranging the multiple model assembly with specified gaps. So next one, visualizing and checking. So we can visualize the battery pack's configuration by using a battery chart. So double click on this. This is our battery pack model. Next, that battery pack in our simulations that we have to convert into Simscape models that used for a future simulations. So to use the battery pack in our simulations, it's converted into the Simscape models that represents the behavior mathematically. So that's why we want to create a library for this particular battery pack. So this is what these models can be used to simulate behavior and integrate them into larger system, designing cooling solutions, develop control. So in future classes, we will see how to check the voltage, current and SOC from this battery pack and battery, and also thermal influences consideration. We will see future classes. So first we want to create battery pack by using these codes. So next, step by step, we will move on. So first, how to check the current SOC and SOH from the battery during a charging and discharging. So that we will see in future classes. This is the step-by-step process. So this is a step-by-step process guides from the individual battery components to creating a comprehensive battery pack model. Yes, Matlab 2220 A version and B version is also available. This is our step-by-step process to create a battery pack model with the Simscape that we have to analyze and optimize the use of the battery system effectively for various research and various simulations. No, Shweta, this code is only for Matlab 22 A version, B version and Matlab 2023 version also. You have to download from the get into PZ, the version Matlab 2022A or a B. Do you have any other queries? Otherwise, we will wind up the session now. So join our internship today. As an internship user, you're getting some hands-on projects like battery state of charge estimation by using a Coulomb and Kalman filter. So these are all the advanced methods and constructing the battery pack with integrated cell circuitry and also creating the battery model, some considering the thermal influences and having a 30 days of live sessions and 90 days of access to records and 10 plus source codes. So in the source code, you have a BMS algorithm and SOH algorithm, SOC algorithms to estimate the state of charge, state of health, and 30 downloadable presentation and also 6 mastermind sessions clarifying your doubts. So join now. So thank you all. Thank you for this. Thank you for your active participation. If you really like this session, give comment in the live chat. If you really like the session, thank you all. Thank you Kumar Shah. Thank you Manjula Official. Thank you. No Shweta, this code is not available in that old version. I don't know. Yeah, I will share. Only internship user. Thank you all. Thank you Ranjani. Thank you. If you really like the session, give heart in the comment box. Thank you Praveen. Thank you Navin. Thank you Supertech. Thank you Manjula. Thank you Balakarthik. Thank you. Thank you Gaming. Thank you Sita Vargala. Ananda Shikar. Thank you all. Thank you Tejashwini. Thank you. Thank you Habibullah. Thank you. Thank you all. Thank you so much. Thank you. Thank you Madhusudan. Thank you. Thank you Deepak. Thank you all. Thank you. Thank you for your positive response. Thank you Suganya. Thank you Ganesh Bala. Thank you. So thank you all for your active participation and engagement in today's class. Thank you so much. So keep up the great work and let's continue our learning together. Thank you Manjula. Thank you all. We will meet tomorrow. Thank you.